Good day everyone. My name is Ivan Urbano.
I'm Salis Bernard T. Freyon with Phil Ardich Cardenio,
And we're here to discuss the
exponential growth and decay.
The first equation we need to be familiar with is this equation dp divided by dt is equal to k times p. So this equation tells us that the population grows at a rate that is proportional to the size of the population. The population growth rate is dp over dt. That's how fast the population is grown at a given time. K is the relative growth rate. MP is the size of the population. At some time T, now for understand is conceptual. Let's say if we have a sample of 1,000 bacteria, and let's say is that in a sample the bacteria grows 50 cells per hour. What's going to happen if we double the population? Let's say if we have a sample of 2,000 bacteria counts. Well, since we have twice the amount of bacteria, we should expect it to grow at twice the rate that is at 100 cells per hour. So, thus we could see that the rate at which the population grows is proportional to the population shocks. So, if you increase the population size, dp over dt will increase. Fortunately, if you double the population size, the rate will be double. If you triple, the rate will triple. Now from that equation, how can we devise a general formula to calculate the population at any time? In order to do this, let's multiply both sides by dt, so that this 2 will cancel and we have dp is equal to kp times dp. Now, we need to separate the variables. Ks are constant, as you said, is the relative. We need to separate p from dt, so let's divide both sides by p. So now we have this expression 1 over p dp is equal to k dt. So at this point, let's integrate both sides. The antiderivative of 1 over p is simply the natural log of pk is a constant. The antiderivative of dt is t, so this is going to be k times t plus the general constant c. So what should we do at this point now that we have this equation? How can we get t by itself? At this point, you want to put the equation on top of e, that is on the x alone, even ln t is equal to kt plus c, and then e raised to ln p is equal to e raised to the kt plus c. Now the base of a natural log is base e, so these two will cancel, and so p is equal to e raised to the kt plus c. Now just review some things in algebra. You know that x squared times x cubed is equal to x to the fifth. We need to do this. You need to add the two exponents. So what if we work backwards? We can say that x raised to the 4 plus 7 is equal to x to the 4 times. So basically we're starting here and going back to this form. Notice that kt is added to c, so therefore what could do is we could say that e to the kt plus c is equal to e raised to the kt times e raised to c. Now h to c is a constant, so we could simplify and replace it with c. So the population is equal to c e to the kt. Yan. Now starting with this equation, we're going to calculate p of 0. Uh, so let's replace t with 0. going to be E times K times 0. K times 0 is simply 0. So this is to be CE 0. Now anything raised to the power of equal to 1. So therefore P of 0 is C times 1. So C is the initial value. It's the population at t equals 0. So we could say C is basically P initial, thus we can replace C of t initial. So the general equation is the population at any time is equal to the initial population t0 e times relative growth rate, which is k multiplied by t. So now you know how to derive this formula from this expression. Let's work on this problem. The table below shows the root of population on a certain island where t is the number of years beginning with the year 2000. Determine the relative growth rate. So we need to use the equation p of t is equal to p of 0 e raised to the kt. Our goal is to solve for k, but first we got to find p sub 0. So, what exactly is p sub 0? Well, p of 0 is equal to 1500. When t is 0, that is the year 2000. The population is 1500. So, if we replace p of t with 1500 and t was 0, we're going to get 1500 is equal to p sub 0 e minus 0 e to the 0 is 1. So p sub 0 is 1500. So p of 0 is the same as p sub 0. That's the initial population. So how can we use this to calculate k? I'm gonna clear this. Yep. So now that we have a value of p of 0, we can say that P of t is 1500. That's P sub OE raised to KT. So now let's use another point to calculate K. We can use any point in the data table, but let's use the first one in the year 2001. T is equal to 1, so the population at T equal 1 is 1577. So let's replace it with t with 1577, unless you place t with 1 in order to solve for k. Let's divide both sides by 1515. 77 divided by 1500 is equal to 1.0513, and that's equal to e raised to k power. So now that is the point, we need to take the natural log of both sides. The natural log of e to the k, what do you think is that's equal to? A property of logs allow us to move the constant or the exporting to the front. So this is equal to k times the natural log of e. The natural log of e is equal to 1, so k is simply equal to ln 1.0513, which is about 0.05. So that's the value of k. So now we can write a general form. mm, is this? Yes. Yeah, there is this. Okay. So to write the general formula is going to be 1500 E. Then all I need to do is replace K with 0.05 times T. So that's the answer to part B. This is the general equation that will give you the population P of T at any time. The answer to part A is relative growth rate is the value of k, which is 0.05. So basically, the population increases by 5% every year, compounding continuously. This formula is the general form of the compound interest type problems. Mm. Now, how can we estimate the population in 2010? To do that, simply replace t with 10. So this is going to be 1500 e raised to the 0.05 times 10, and just type it in your calculator exactly the way you see. 0.05 times 10 is zero point 0.5, so it's 1500 times e raised to the zero point 0.5, and so the population is going to be about 2475 73 rabbits, and it will the year to 2010. How many years will it take the population to double? And that's starting from the year 2000. What we're going to do is we're going to find out how long it takes for the population to double from 1500 to 3000, because 1500 times 2 is 3000. So let's replace p of t with 3000. Yeah, we're just gonna solve for the variable t. Mm. So let's get rid of a few things. Um, So our first steps is to divide both sides by 1500 divided 3000 divided by 1500, simply 2. So 2 is equal to e raised to the point 0 times t. Next, we need to take the natural log of both sides. This will allow us to take this exponent move to the front. So the natural log of 2 is equal to 0.05 times t multiplied by the natural log of e and the natural log of e. So natural log 2 is equal to 0.05 times t. So the time it takes for it to double is simply ln 2 divided by the rate constant k, the relative growth rate. So if we divided these two numbers, ln 2 is like 0.6931 divided by 0.05. So it's going to take um, 13.86 years in order for the population to double. Let's round that. The nearest whole number is approximately 14 years, or we could say that the year 2014, the population will be above 3000.
So,
Thanks for watching the video.